We focus on big data and information management and application development services, as well as data analytics. We have offices in Austin, New York, and Phoenix. Today's presentation is going to be done by Rakesh Soni, who is our Big Data Practice Director, Randy Ludwig, PhD, one of our data scientists, and Daniel Lai, one of our data scientists. And with that, I'm going to hand it over to Rakesh.
Thanks, Emily. Thanks for organizing and kicking off this great webinar. Thanks to everybody for finding your valuable time and joining the webinar today. In today's webinar, we bring you one of the hottest and sexiest 2017 IT trend as recently predicted by Gartner, and that is machine learning. Today's webinar is divided into two parts. First, we will cover a presentation explaining what is machine learning with a few real examples that all of us basically have seen around us. Followed by main feature of Azure Machine Learning Studio, like how to import and export the data in and out of Studio, how to do a data profile and see many statistics that are required when you are building a data science model on a daily basis. You will also learn about a very important feature of Azure Machine Learning Studio, that is public gallery, that can help you kick off your model in a very fast way because there are already a lot of published models by many of the data scientists in the gallery. We will end the presentation by sharing a very good cheat sheet with you guys, which you can use wherever you have a problem and you are trying to decide which algorithm will best fit your business problem. You can use that particular cheat sheet. The second part of the webinar will cover two machine learning models. In the first demo, Daniel will give you a walkthrough of a simple data model that uses data to predict income category. In the second demo, Randy will give you a walkthrough of a little bit complex model for predicting patient admission. With that, I'm not going to take much time from you, and I would like to invite Randy to continue. Randy, please go ahead.
Thanks, Rakesh. So let's talk a little bit about machine learning and what exactly that means before we move into exactly how it's implemented in Azure ML Studio. So first of all, machine learning already exists in many applications around us in the world today. Some of the most high-profile instances that you might be familiar with are strategic gameplay, where a computer optimizes its actions in a game based on which ones will lead to the highest reward. And another example is self-driving cars, which are reinforced through human decisions and data to human decision making to be able to mimic closer and closer actual human decisions without intervention by humans. So that same style of machine learning, which can teach computers to make decisions like humans do, can also give us a lot of leverage into business problems. So one of the things that it can really do for us is help us predict behavior for things that we don't necessarily have data for. So an example of that might be future customer behavior. You want to be able to get insights into what you think customers will do next quarter, next year, things like that. But you can also predict for data sets that you don't have yet, like new groups of customers, and comparing them to old groups of customers to predict what you might expect their behavior to be like. So it has a lot of flexibility for giving you insight into things that you don't already know, but it also can give you insight into real-time decision making that customers are doing. So there's a lot of possibilities there. So how exactly does machine learning do this? The first thing it does is it takes raw data from the real world as an input to a model. So the model is what we're talking about when we talk about machine learning algorithms. That model has a set of parameters within it that it uses to make a decision and come to a prediction for the given data that it has. Then it takes that prediction and compares it with the truth. This is one way machine learning can work. You can compare your predictions versus reality, and then there's an aspect to the model which is called the learner, which compares how close you are to reality and modifies the parameters accordingly so that you get closer and closer to the truth. So you go through this cycle of making a prediction, comparing it, modifying your algorithm, and going over and over and over again until you get closer and closer to the actual outcome. And then you can apply that model once it's refined to data sets that you don't already have, where you don't know what the truth is, and then you can get predictive behavior that way. So let's look into how Azure implements machine learning in Azure Machine Learning Studio. First of all, so this is the web interface that you'll see when you log into Azure Machine Learning Studio. You have a whole host of different ways that you can use this. You can organize all of the work that you have into projects. The experiments are where you're going to do your modeling. You can import different data sets into your models, and then once you have a model, export it as a web service or to a Jupyter notebook for further exploration. All of this is fully shareable, cloud managed, and collaborative. So you can share your workspace with other people so that you can collaboratively build a model, or you can use it as a way of sharing what you have already done to other people to help them understand your modeling process. So as a visualizing tool and sharing the story of what you're doing in your modeling process, it's very, very helpful that way. So once you have your drag and drop model that you've built out of the modules that Azure ML provides, you can build and test and deploy that model to various applications. You can send it to various web services or custom apps or BI tools, wherever you need it. So it's, the input and output aspects of Azure ML are very flexible to allow you to use it in whatever way works best for you. But you don't have to start from scratch. As Rakesh mentioned in the intro, there's a lot of people who have already been using Azure ML Studio and have made models for various kinds of problems. And if you can go there and look for someone who's already maybe tried to address an issue very similar to what you're looking into, you can actually get access to their public model, input your own data set, and with maybe a little tweaking, get your own predictions out with very, very little work. So this is really, really useful, and it really embodies the spirit of the collaborative data science process, where you don't have to reinvent the wheel because people are constantly coming up with new things, and so you can all benefit as a community from existing models that people have built and put a lot of time and thought into. But it also has the flexibility for you to do everything from scratch yourself. So if you open up a workspace to do your own experiment and build your model from scratch, this is what you'll see. On the left, you have a list of all of the possible kinds of modules that Azure ML has built into it. All of those have drop-down menus that have a lot of different options in them. And once you find the module that you want for whatever part of the process you're in, you just drag it over to the right and then start building out your workflow from there. And again, this is all fully shareable and collaborative and cloud managed, so it updates live for anybody who's working on it as long as everyone has the same shared space. So the first thing you need to be able to make a model is to have data. So you can import data from a host of different places. Over on the left side here, you can bring in data from any of the Azure storage capabilities. You can bring in from SQL databases, or if you want, you can bring in from flat files that are local. There's lots of options to get your data into Azure ML Studio so that you can start to work with it. And then once you've modified your data using your model, you can export it in a host of different ways as well. You can export it to, again, the same Azure storage options, Hive queries, flat files, the same sorts of things. So you can import and export your data in lots of different ways to get it into this interface. And once it's here, then you can create a model with it. So this is a sample workflow of a model that's been built for binary income decisions for different adults in the census. But what we really want to illustrate here is that there's nonlinear aspects to model making. This is a pretty simple model, but you can have very, very complex models. And if you're showing that, if you're sharing that with other data scientists or other people who want to understand your process, sharing that in terms of live code or a notebook, which is all very linear, becomes very hard to quickly pick up what's going on. It's much easier in this visual interface to see what's happening and share the story of what happened in your process. So let's talk a little bit about what happens in this modeling process. The first thing that you can do is if you right-click on the data set that you brought in there at the top, you can get this option to visualize it. So if we visualize that data set, you get instant summary statistics of your entire data set. This is one of the things that I love most about Azure ML Studio is the quick ability to explore your data set. Even if you don't use it for modeling purposes, just the ability to quickly and cleanly glance through your data set and try to figure out what you even want to do with it is very, very powerful. And so here we can see how big our data set is, how many columns it has, so that's how many possible features we would be able to use in our model. We can click on any of those columns and see instant summary statistics over on the right-hand side. We can also, one of the other things that's very useful is the number of unique values and missing values, which can give you a lot of guidance into how your cleaning process is going to go. And then you can do various kinds of visualizations of that data. And again, this all happens practically instantly. So it's really, really powerful for even just exploring your data set and figuring out what the possibilities are. So once you decide what the possibilities within your data are, you'll have a certain kind of problem that you're trying to answer. You might be doing a classification problem where you're classifying things in one class versus the other. You might be doing regression where you're predicting an actual value, or you might be doing anomaly detection. And these are just a sampling of the built-in algorithms that Azure ML Studio already has ready to go to model your data with. And so this is just kind of a cheat sheet of which of those models you would use in which situations and some of the benefits of those. But again, another one of the really cool things about Azure ML Studio is that this is not all the algorithms that are there, and in fact, the number of algorithms is growing all the time. Just even in the weeks that we've been preparing this webinar, the number of models that are available has grown like 20 to 30%. So there's a lot of continued development in this platform that continues to make it more and more powerful and more easy to use for the data scientists. Once you have a model, you can take your model from Azure ML Studio, as shown here in the middle, and publish it to a web service. So you train your model on your data. You can then apply it to other data sets. So if you publish it as a web service, then you can interface that with all kinds of different other outputs. So you can interface that with an app, a website, BI tools, however it is that you want to consume the information that you get out of your model, whatever your predictions are. You can consume them in a whole host of ways that are all able to interconnect with this interface, the web service interface. So it's really, really powerful. It's a quick and easy tool to use, and then it can get data in and out from basically most of the places that you would want to do that anyway. So it really, really has a lot of flexibility for data exploration and quick data modeling to explore the possibilities within your data set and what kind of answers you can come to. So with that, we're going to get into a little bit more of nitty-gritty and actually build a model here live, and I'm going to pass it off to Daniel to do that.
Hey, hello, this is Daniel. Thanks, Randy. So today, this is the model that we're going to look at. We're going to take some adult consensus income data and then try to classify what income category they belong in. And we're going to do this from scratch, so it's going to be fun. So right now, we are in the experiment section of Machine Learning Studio. What we want to do is go to New, Blank Experiment. So now, we want our data set first, so we're going to go grab the census data. So first off, we're going to visualize it, and it's very easy. Let me do that again for y'all. So all you have to do is click Visualize over here, and you get rows of data that you want to look at. And today we're going to try to predict this income column. As you can see, it's consisted of people below 50K and above 50K. So this is a really powerful tool for building kind of like your workflow and understanding data science better. The first step we're going to do is we're going to select some columns that we're going to use for our models. So we're going to do select column, and it's very easy. You just go over here, put select, and what we want to start off with every column. So just go to rules, all columns, and then come back, click OK. And so you have every data set, and you can always verify at each step what you have. So let's run this. Okay, see. So we visualized it. We have all of our columns. Okay, so now we want to build and train our model. So what we're going to do first is we're going to try to split the data up so that we have a version of reality and a version for data for our training. So what we want to do, we want to split the data from our data set up into our training set and our test set. So our test set is going to represent reality, and our training set is going to help us train our model. So what we want to do is we want to grab the train model right here. So you can just type train model on the side. So first off, a really good thing is that they already have these holes here, so you know where to plug in everything. So this data set will go into this data set hole with the link. And right here we want to put our algorithm. And just go into the classification section of our modules. We can see that Azure ML provides a lot of solutions over here, and these solutions are continually growing, and it's very expansive and very well documented. But the one that we're going to look at today is going to be a 2-class boosted decision tree, which is a very powerful model for classification. Right now we're not going to worry too much about the parameters being set, but so right here, there's a number of leaves, the number of samples of leaves, there's the learning rate, and there's a number of trees here. And all you have to do is go over to the train model and train it on a certain column. And today we want to train it on the income column. So now we have our training model. What we want to do is we want to test whether or not our training model does a good job of representing reality. So all we have to do is go over here, do score model, just like test model, and then we want to link our training model towards our score model. And then we want to bring the test set, which is our version of reality, to the score model so that it can compare. And just run this. Okay, so the result that we're trying to expect from our score model is a column of probabilities that show us the probability that that this person belongs in the greater than 50K category. So if you look down here, we have mostly people that don't belong in that category. And next we want to look at what are some of the important features in a complex model like boosted decision tree. So what we're going to do is we're going to use this very special module called Permutation Feature Importance in Azure Machine Learning. And it simplifies your whole analysis process. So we're going to link the training model right here, and then compare it to reality. So you're going to go in here. And if you didn't want to run everything, you could just click on Run Selected, which is what I just did. Now let's look inside. So after visualizing, we can see that a couple of the biggest factors are your marital status, your capital gain, and your education level. And all the rest seems to be about the same level of magnitude. So that would indicate to us that these three are the top indicators of whether or not someone is above the income of $50,000. And now we want to see how our classification performs. And all we have to do is we want to evaluate our model. So we want to just easily grab out the evaluate model module, link it to the score model, and then run this and select it. So it gives us this really pretty picture of an ROC curve. And it also gives us statistics on the true positives, the false negatives, false positives, and true negatives. And it also gives us the accuracy, which in this case we got an accuracy of 87%, predicting which category of people you belong in terms of income, and also the F1 score, which is a good indicator of classification accuracy. So, and this is and if we want to look at whether or not we can switch some columns to input into our model, we can just go to the select column and then maybe take out some of the variables that were giving us negative predictions, which is, I think, relationship, and also race was one of them, and let's just do those two. So very easily you can just get rid of columns that you think are bad for your model, and then you can just rerun this thing. And you want to just OCaml raise your data set so that you don't have that much noise. And after we look at evaluate our model again, I'm going to hand it off to Randy for a second model. So. Yeah, and so you can see in the span of about 10 minutes, we were able to build a really simple model, and then also filter through some data that we thought was noise. And you see that the accuracy didn't really change, so that means that those two columns didn't really add to your classification accuracy. So thank you guys so much. I'm going to hand it off to Randy.
Thanks, Daniel. Let's go ahead and look at another model here. So this is our second model. What I kind of want to show you guys with this model is a little bit more about, Daniel showed you how powerful and how quick you can be using Azure ML Studio. What I wanted to show is how flexible the studio is and how customizable it is. So there's a lot of exploratory options that you have here, like we talked about before. So what this model is going to do is predict for a set of diabetes patients which of them are likely to be readmitted to a hospital for treatment. They've already been to a hospital for treatment before, and we want to know how likely it is that they're going to come back for more treatment because their diagnosis was wrong, or whatever reason there might be. So let's go ahead and visualize our data again. So here we can see we have 30,000 patients and 45 columns. So that's a lot of possible features to go into our model. And if I scroll through here, I can start to see some of what those columns are. So here's diagnoses they have had in the past. Here's different kinds of tests that have been run on them, or drugs they may have tried to address their diagnosis previously. And then here, this column right here is what we want. This is the readmission class. So this is yes or no, they were readmitted to the hospital. So that's what we're going to try to predict with our model. So the first thing we can do here is clean missing data. So Daniel showed you for any rows that have missing values, you have several options here for what you can replace with. You can replace with mean or median for numerical data, or for categorical data you can replace with the mode, or you can do a host of other things as well. What we're doing is anything that's empty we're replacing with a 0 just to have a value in there so that the model can run more easily. So the first thing I want to kind of show you guys is how quickly you can just test out different kinds of models. Like when you first start trying to answer a problem, you don't necessarily know the best way to go about solving it. So the first thing I want to know is, out of the host of models that I have here available to me, which ones are going to work best for me. So this problem is a classification problem. Is a patient going to go back to the hospital or not? Yes or no? So let's look in the classification module and see all the options we have here, which Daniel showed you a minute ago as well. Since this is a yes or no question, it's a 2-class module or a model, so we're only going to look at these down here at the bottom. And you can see there's a bunch that kind of fall in the decision tree type of solution, and then there's a bunch of others that are a whole host of other ways of going about this problem. So the first thing I want to do is just kind of try a couple of decision tree type of models to see how they compare with the data that we have. So let me just close this out and move this over. So these are the 2 models that I selected, so Decision Jungle here and a boosted decision tree. And so what we've done is also just want to show some of the common data science methodology that people use in their modeling to show how easy it is to do that in Azure ML Studio. So the first thing we're going to do here is cross-validate these models with our data. What this is going to show us is how generalizable this model is going to be to new sets of data. So we're going to train it on some set, but we really want to know if it will predict a set that we haven't trained it on. And so this kind of gives us a sense for how general this model can be. So we've run these. Well, first of all, I want to show you guys what options there are with these different kinds of models. So first off, let's look at the Decision Jungle. So these are the types of parameters that you have available to you. For this part, we're just using all the default values, but this is, you can change any of these custom parameters. For the boosted decision tree, it's the same ones that Daniel showed a minute ago. And so again, those are parameters you can change, but we're just going to use the default values for now. And when I ran the cross-validation on that data, I want to evaluate the results here. And so what this is going to give us is the same evaluation parameters that were in the evaluate module: accuracy, precision, recall, F-score, and what the answer was for those for each fold in the cross-validation. And so what I really care about is down here at the bottom, I have the mean and standard deviation for all of those measures. So for accuracy, which is what I'm going to compare for most of these, this Decision Jungle has an accuracy of 0.62 with a standard deviation of 0.008. And if we look through these numbers, we can see they're not really varying much, and that matches up with what we would expect. So that's kind of our starting point for this kind of model. So then let's see how the boosted decision tree does. And I'm going to drop down the notes here, which I just wrote the accuracy and the standard deviation, so that way we can compare them later. So let's look at how the boosted decision tree did. And we can see here these accuracies seem to be higher. Let's look. Yeah, so our mean accuracy is 0.64 with a standard deviation of 0.015. So there's a little bit more variation, but overall we have a higher accuracy. So this seems to be a better model than the Decision Jungle based on the accuracy alone. So there's those numbers just for reference. The other thing I want to do is use the evaluate module to compare them directly. So here we have our ROC curve again. The blue line is the left model, which was our Decision Jungle, and the red line is our right model, which was the boosted decision tree. So you can see that for a given false positive rate, the number of true positives that are being picked up by the 2 models, the boosted decision tree is always outperforming the Decision Jungle. So that's promising. And then going down here, we see the same numbers again. So our accuracy was 0.64. This was for the boosted decision tree. If I select my decision jungle, it's at 0.62 that we talked about before. So this matches up with what we got out of our cross-validation module, and it's just another way for us to compare these two models. So out of these two types of models, it looks like the boosted decision tree is going to perform best. But what if we use an algorithm that's very different than a decision tree? So let's move over here, and I've got a couple of other models that are substantially different than a decision tree. So we have logistic regression here and a neural network, which perform, which work very differently than a decision tree does. So let's look at the output from the cross-validation here. So again, just comparing the accuracy, this performs about as well as the decision jungle did. The accuracy is 0.62 and a standard deviation is about the same. So let's drop that down for our comparison. And then for our neural network, let's check how it did and how generalizable it is. Our accuracy is far and away less than it was for all of the other models. So actually, a lot of people really think neural networks they are really powerful and really good models, but they're not necessarily the best solution for every problem. And in this case, they're not the best solution for this problem. There were multiple other models that outperformed it. So that's definitely not the model we want to move forward with. But let's go ahead and just look at the curve just to confirm what we're seeing. And again, the blue is the left model, the red is the right model. So yeah, you can see the blue is way outperforming the neural network, which is the red. So, and again, these numbers down here are going to match up with what we showed before. So, based on quickly exploring 4 different kinds of models, so that just took us a handful of minutes to explore many different kinds of modeling on the same data set. So that's one of the things that's really useful about Azure ML is the ability to quickly explore your data and explore solutions for your data to come up with a way to get a more refined model to move forward. So what we want to move forward with is our boosted decision tree. So then let's go down here. We have our data set that we cleaned. We're going to split it into a training and a test set. So the way that we did that here was just say we want to keep 70% to train our models, and we want to keep 30% out to test later. So that's our confirming with reality again. So coming down here, what we did up here for cross-validating, we kind of want to do again. So the way that we're doing that is through a partition. So we're partitioning a sample into 5 folds, and we're going to use that to have a more refined model and cross-validate it. So again, this is exactly the same kind of model that we decided was best up top, but rather than having the default parameters, which was what we had before, here what we're going to do is we're going to allow Azure ML to sweep through the parameter space and find the optimal combination of parameters to model this particular data set. So what that is our tune model hyperparameters module. So the way that we're going to do that is we make a random grid of all of those parameters that we just showed, and we're going to do 50 different models with different combinations of those parameters and see which combination of parameters performs best for this data set. And that's going to tune our model to be more precisely, have more powerful predictions for this particular data set. So the output of this is a tuned model, the trained best model, and then we're going to apply that best model to our data. So the score model module here is what takes your model and makes predictions from it. So let's actually look at the output from the score model module here. If I look at the output, what I see is, so I have my data set, this is all the same stuff we had before, but what I have at the end is, this was the actual data, the readmission class. This is the predicted label based on the model, and this is the probability that any given row falls into either a yes or a no. So 0 is a no and 1 is a yes. And so depending on where you set the cutoff there, different things will get classified as a yes or a no. And if I look at the histogram here, I can see that I have things very close to 1, things very close to 0, and there's substantially fewer that are really in the middle. But so you can choose kind of anywhere in here to draw your line based on how important it is to you, whether you get false positives or false negatives. For right now, we just cut it 0.5, and everything above 0.5 is a yes, and everything below 0.5 is a no. So now we have our predictions from our model. So what can we do with that? Well, there's several options. The first thing I want to show you guys is, let's do the same thing that Daniel did and do the permutation feature importance here. So like he said, what this does is it runs through your model and varies the features, the columns that are included to predict the outcome, and tells you which columns are most important for your model. So if I look here, the columns that are most important for our model are the number of inpatient visits this person has had, the discharge disposition ID, and the number of emergency room visits, and it goes down from there. But one other thing that you can go look for, so these don't contribute to my model at all. They have zero impact on the model. But more interestingly, these negative ones actually sorry guys. These negative ones actually okay, sorry about that, everybody. These negative features actually detract from the accuracy of our model. So ideally, in a longer model, we would want to take those out so we can actually write custom code to implement in our model as well. So one way we can customize it is using SQL. So here I just have a quick query to pick the top 3 features and the readmission class that we could then take the output from this into a new model and try to get even better results. But then we can also do a lot of other custom things. One other thing we can do is convert to a CSV file, which then can be output to a Jupyter notebook. You can use R scripts or Python 2 or 3 to do further analysis. We also can do our evaluate model, which gets our errors again and our accuracies for this model. We can execute custom Python script or R script to visualize our results. So let's look at that real fast. Here, let me show you. So in this window over here, we have our script, which is just a plotting procedure, and we will output that. And here's our plots. So you can quickly evaluate within the workspace how your models do. And for the R script here, like I said, we can tune where we want that cutoff to be. We set it at 0.5, but we can make it be anything. So if I visualize here, we can see that actually maybe the better place to have our cutoff might be closer to 0.2 or 0.1. So there's lots of options there for how we want to classify our data. So these are things that you can use to customize your model and move forward to get an even more accurate prediction. All right, so that's kind of an overview of all the things that we can quickly show you that Azure ML Studio can do. I'm going to pass it off to Daniel to go over the summary.
So yeah, we just want to sum it up with talking about what we went through. We've looked at Azure Machine Learning as an interactive and visual workspace, supports various data sources, and also is this great GUI for building your workflow and exploring just the data with deeper insight. It also includes just this expansive set of algorithms that are made, and also it can be integrated with a lot of the data scientist tools that people use, like SQL or Python, and just a great tool overall. So thank you. So yeah, all this information can pretty much be found on the Azure Microsoft documentation page. And we're going to open this up for some further questions.
Yes. If you've got a question, please feel free to pop it into the chat field. Randy's doing a bit better, so she had a little, I think T went down the wrong tube, but don't worry, Randy's okay. So if you've got a question, please send it through the chat field and we will be happy to get that answered for you.
So somebody asked about how long it takes to make a more thorough model using the Azure ML Studio, and it really completely depends on what it is that you're doing. These were all prepackaged data sets that come with Azure ML for exploration purposes, but I've actually played around with importing some much less clean, bigger data sets just to see what it's capable of, and spent several days to weeks just cleaning it and using Azure ML's interface to be able to play around with the data before we even tried any modeling stuff. Like you see, if you know what you want to do already, it can be very fast, or if you know what kinds of things you want to do to test, you can do that very quickly. But if you're still kind of getting a feel of what the possibilities with your data even are, it can stretch out to as long as you want. So it really is fully customizable with the notebooks and the custom Python and R that you can write, and SQL. You can, however long it takes you to do a typical model in your own process, it can be faster, but it can also take as long just because you can do all those same things.
Daniel, we've got a question in the chat field. Is Azure free to use?
So I think it's free, but when you want to process more data, I think there's like a fee on top of that. So
yeah, there's a free trial period where you can do pretty much anything that you want, but then to get the full processing capability for longer term use, you can pay per use, basically.
Yeah, Azure's charged on a consumption basis, so hopefully that answers your question. We have another question coming in. Can it be installed on my local cluster?
So Azure runs on a cloud platform, so everything has to be brought into Azure itself, which is run through the web interface. I don't think they do local installations of it because everything happens in the cloud.
Great. Well, do we have any other questions out there before we wrap up the webinar today?
any data science questions, any pain points you guys want to look over? Now's the time.
So this presentation has been recorded, everyone here will get an email tomorrow with a link to the recording, and we'll also make sure that you have Daniel and Randy's contact information. So as those data science questions and pain points come up, please feel free to reach out to the team here at Intersys, and we always like to keep it open and keep it collaborative. So I would like to, big thank you to Rakesh and Randy and Daniel for your time today and this great presentation. Thank you to all of you who joined us, and I hope you have a wonderful rest of the week.
Thank you. Please stand by.